Here is a rational function on ALEKS, and our goal is to be able to graph the function on ALEKS. So we're going to begin by using the graphing steps that we learned, and in ALEKS they require us to draw the asymptotes, and they always want us to plot at least 2 points on each piece of the graph. For our class, though, we did not do that, so we were always graphing just a sketch once we determined where the curves were, but on ALEKS they require you to have some points to connect. Once you have plotted your points and you've set everything up with the asymptotes at the very end, you will click the graph icon. So this function is 2x plus 1 divided by x plus 2. So let's find some x-intercepts. So x-intercepts are where we set the numerator equal to 0, and we solve that equation for x. So I get an x-intercept at -1/2, comma 0. So I'm going to plot on ALEKS a point, and I can type in, using this fraction key here, -1/2, 0. So anytime you have a fraction in your ordered pair, you should use this feature on ALEKS to plot the exact point. So plot that point. Okay, so now let's see if we have any y-intercepts for this function. So we have y-intercepts are where we plug 0 in for all of the x's. So 2 times 0 plus 1 divided by 0 plus 2. So that simplifies to 1/2. So 0 1/2 is another ordered pair that I can plot. So I'm going to grab this point plotting tool here, and my x coordinate is 0, and for my y coordinate I'm going to pick the fraction and I'm going to type in 1/2. Plot that point. Okay, so now we're going to solve for any asymptotes for the graph. So the vertical asymptotes come from the denominator, and we're looking for restrictions in the domain. So we set the denominator equal to 0 and you solve for x, and this is a dotted vertical line through -2 on the x-axis. So we're going to plot this dotted vertical line, and it looks like I can just drag it right to the number -2. Okay. Now let's find any y-intercepts. Asymptotes that are on the y-axis. So horizontal asymptotes, that requires us to compare the top degree with the bottom degree. There are 2 cases that we're going to graph. If the top power n is less than the bottom power m, then we have a horizontal asymptote at 0. If the top power n is equal to the bottom power m, then the horizontal asymptote is the quotient of the leading coefficients. So in this case I have x to the first over x to the first. So this is the case where the top power is equal to the bottom power. So my leading coefficients are 2 over 1. So y equals 2 over 1 simplifies to the line y equals 2. So let's plot the horizontal asymptote through 2 on the y-axis. Okay, so now that we've got that information, I want to see, does the graph cross that horizontal asymptote? So we set the equation 2x plus 1 over x plus 2 equal to the horizontal asymptote value, which I got to be 2. Cross multiply. 2x plus 1 times 1 is 2x plus 1 equals 2 times x plus 2. So if you distribute, you get 2x plus 4. Now if we solve this equation for x, we'll see that the x's cancel, giving us a no solution. So when it's no solution, we would say no, the graph is not going to cross the HA anywhere. When we have a single vertical asymptote, our picture is going to look like, let me graph this here. Our picture is going to be an odd function. So if you have a curve in this upper quadrant, then the other curve will be down below. Now it looks like I've got a situation where I have the curve I know for sure I've got a curve down here in this bottom quadrant because I have 2 points on the graph there. So I know that the other curve will be up here. Now I've already got 2 points down here, so ALEKS requires us to always plot 2 points for each piece of the graph. So I've got this part taken care of, but this part has no points to plot. So I need to figure out 2 ordered pairs. So if you look at the location of your vertical asymptote at -2, you need to plug in any 2 numbers that are further to the left of it. For instance, I could plug in -3 and -4. So I'm going to go to the original function and I'm going to plug in x is -3. So in the equation I have 2 times -3 plus 1 divided by -3 plus 2. On top that's -6 plus 1, which is -5, and on the bottom -3 plus 2 is -1, and that simplifies to 5. So I can plot a point -3, +5. So let's go ahead and graph, and I'm going to pick this point plotting tool here and I'm just going to type in -3, 5. Plot the point. Now let's plug in x equals -4. So I have 2 times -4 plus 1 divided by -4 plus 2, and that's -8 plus 1, which is -7, over -4 plus 2, which is -2, and that reduces or simplifies to just a 7/2. So now I want to plot the point -4, comma, +7/2. So x is -4, and for y I'm going to pick the fraction and type in 7/2 and plot the point. So I've set up everything I need for my graph. I have the asymptotes, I have 2 points for each curve. So now if I just hit my graph icon, which is this curve icon with the 3 dots on it, that should graph for me.